Okay, everyone. Assalamu alaikum. Let's begin. So we are starting this session now. So again, as I said, we will be doing practice questions on functions in this particular session. If you have any questions from the worksheet or from any recent papers, let me know about them. So I only have a message from Hazem yet. What about the rest of you? Have you attempted the questions? Any problems? What about the rest of you? How many of you are done with all the assigned questions from the functions worksheet? Okay, and you did not have any problems? Rijal, Abdurrahman, what about you guys? Okay, so let's start with some of these questions then. So I'm going to start with this question number 36 from the worksheet that Hazim is asking about. And then we can see if there are any other problems apart from that as well. Question number 36. Okay, so this looks like a good one. This is actually one of the types of questions that I wanted to discuss in particular in this class, where you have a function defined as using two separate expressions. So for one part of the function, we have one expression. For some other values of x, you have another expression. Let's try to look at this question to understand how to deal with problems like these. Okay, so this is question number 36 from the worksheet. Okay, so what you have here is you have a diagram that shows part of the curve y equals 11 minus x squared and part of the straight line y equals 5 minus x. They meet at the point A, this point A. This point has coordinates P and Q. We need to first find the values of P and Q. Okay, so the first part just requires you to find the point of intersection of these two functions. One is y equals 11 minus x squared, and the other is y equals 5 minus x. Point A is the point where these two graphs meet each other. You have a curve, you have a straight line, and the point is where these 2 points, where these two graphs meet each other. So that's the point of intersection of these two graphs. How do you find point of intersection of any two graphs? You solve them simultaneously, right? So you just have to solve these two equations simultaneously in the first part. One equation is y equals 11 minus x squared, and the other is y equals 5 minus x. Let's solve them simultaneously to find the point A. We can equate both of them. We have y as the subject in both of them. So that gives us 11 minus x squared equal to 5 minus x. Take everything to one side, and that will give you x squared minus x minus 6 equals 0. And now you can factorize this. In this case, I think you can break the middle term like this. Yeah, so you can x squared minus 3x plus 2x minus 6 equals 0. That gives you two factors. Showing these steps is important. Solving quadratic equations is part of your syllabus. You cannot just input this directly in your calculator and write down the answer. You can do that for verification. However, you still have to show the working, all right? Otherwise, you will not get marks for solving quadratic equations, particularly in paper 1. In paper 3, you can sometimes get away with this, but in paper 1, they always deduct marks if you do not show the working for solving quadratic equations. So I would recommend that you always make a habit of this. Always show the working here. It doesn't take that much time, just a few extra seconds. You should not risk losing marks because of that. Okay, so you have these two factors, x minus 3 into x plus 2 from this. This step in particular is very important. And then you can write down the answers. You have x equals 3 and x equals negative 2. Now, if you look at the diagram, the point of intersection that we have here, it is supposed to be a positive value. The x coordinate is supposed to be positive and the y coordinate is also positive. So that means we're not going to consider this value. X equals -2. That's not a value that we are going to consider. We only consider the positive value and we say this is the point A. This is the x coordinate of the point A. Okay, this is not possible because on the diagram, point A is supposed to be on the right side. Now, what about the corresponding y coordinate? We could put this value back in any of these two functions. Putting this in the linear function is easier. Let's just put that here. Y equals 5 minus x. That means 5 minus 3. The value of y turns out to be 2. So the point A, therefore, equals 3 and 2. Okay, that's the point that we were looking for. Now, they basically asked us to find the values of P and Q, and they told us that the point A has coordinates P and Q. All right, so we should write the values of P and Q here. Let's compare with what they have given. They have given us that the point A is P and Q. So that means the value of P is supposed to be 3 and the value of Q is supposed to be 2. You should write down these values like this. Okay, so that's the first part, pretty straightforward. You just solved these equations simultaneously and you got the values of P and Q. Let's look at the second part of this question. Now it says the function f is defined for the domain x greater than or equal to 0 by this thing. Now you see f of x is equal to, so there's a function of x that's defined like this, 11 minus x squared for x between 0 and p, and 5 minus x for x greater than p. Now it's a single function and it's defined using two separate expressions. Now we already know the values of p and q. So what we can do is we can write down the domain of this function like this. You can say the domain is actually supposed to be, so the value of p here is basically 2, because we know this point is 2. Let me just check. It was 3, sorry. This point is 3. And this is also 3. Okay. So the first expression, 11 minus x squared, that is valid for x between 0 and 3. And the second expression, 5 minus x, this is valid for x greater than 3. Okay. So basically the graph that you see here in the first part, that's the graph of this function. You can see from 0 to 3, you have this curve. And then from 3 onward, you've got this line. So this is how this function is represented. When x is between 0 and 3, we would use this part of the function. When x is greater than 3, we would use this part of the function. Now what they're saying is, express f inverse of x in a similar way. Okay, express f inverse of x in a similar way. Now, how do we think about this? Let's try this. Part 2. Let me write that function here. It says f of x, that is equal to (11 minus x squared). And this is valid for x between 0 and 3. And then 5 minus x for x greater than 3. We need to define f inverse of x in a similar way. Now, since there are two parts of this function, we would need to find the inverse of both of those parts separately, because one is a curve and the other is a straight line. One is a quadratic curve and the other is a straight line. So first of all, let's talk about this part. So we have one part of the function that can be written like this: f of x equals 11 minus x squared. This is valid for x between 0 and 3. We consider this part separately. And the second part separately, 5 minus x, this is valid for x greater than 3. How do you find inverse of a function? You start with this. You say, let y equals f of x. That gives you y equals 11 minus x squared. 11 minus x squared, that is equal to 3. make x the subject. When you make x the subject, that gives you x squared equals 11 minus y. Now you take square root on both sides, but remember, whenever you take square root, you have to put plus minus. So it's plus minus square root of 11 minus y. And then, as you do with quadratic functions, when you're looking for inverse of quadratic functions, you first have to, when you take square root, you have to decide whether you want to be using the plus value or the minus value. Okay. So which one should we choose here? You can see the domain is from 0 to 3. That means x is supposed to be a positive number generally. It can't be a negative number. So how can you get a positive number from 0 to 3? You would get that with a positive sign here, right? So you should be using plus when you take square root in this case. So it becomes plus square root of 11 minus y. Now you can change the variables. You can say f inverse of x, that equals 11 minus y square root. Okay, so this is one part of the inverse function. We will see how to write it at the end. Let's leave it like this for now. We'll come back to it.
Sir,
First, yes?
sir, isn't it 11 minus x?
11 minus x, sorry. Thank you for pointing that out. This is 11 minus x, which you should not forget, like I did, to change the variable at the end, right? So it's 11 minus x square root. Yeah, thank you for that. Now, then you have f of x equals 5 minus x. All right, that's the other part of the function. You also have to find the inverse of that part. You say let y equals f of x, and that gives you y equals 5 minus x equals 5 minus y, and then f inverse of x equals 5 minus x. That's the other part of the function. Now, the question said that you have to express f inverse of x in a similar way. So you have to express it like this. Okay, now let's try doing that. We are getting that f inverse of x, this should equal square root of 11 minus x. This is one part of the inverse function, square root of 11 minus x, and the other part is 5 minus x. These are the two parts of the function. But now the problem is, since we have to define it in a similar way, we also need to write down the domain of each of these two different parts of the function. So we need to write down what the value of, what the possible values of x are in both of these expressions, for both of these expressions. Now, how do you figure out the domain of the inverse function? Remember that? How do you find domain of the inverse function? In order to find domain of the inverse function, you can say it's the same as the range of the original function, right? Remember the connection between domain and range of inverse functions? Domain of the original function is the range of the inverse function, and the range of the original function is the domain of the inverse function. Since you're looking for the domain of the inverse function, we can figure out the range of the original function. Now, let's think about this first of all. 11 minus x squared. This is the domain of this function from 0 to 3. All right. Let's look at the graph. This is the first part of the function. X is from 0 to 3. Now you can look at the graph and see what the range of this function should be. You have already found this point A. This point has coordinates 3 and 2. So that means the y coordinate here is 2. What about the y coordinate here? What's the y-intercept of this curve? You can input x equal to 0. When you input x equal to 0, the y value turns out to be 11 in this case. So that means this point is 11. So what's the range of this curve? 11 minus x squared. If the domain of this curve is from 0 to 3, the range of this would be from 2 to 11. This would be the range of this function. Now, let me write that down here. Just for reference, the first part of the function, the range of this is from 2 to 11. What does that tell us about the domain of the inverse function? This domain for square root of 11 minus x should be from 2 to 11. Okay, this should be from 2 to 11. Make sense? The range of the original function is from 2 to 11 for this part. So this should be 2 to 11 as well, the domain of the inverse function. Now, similarly, look at what's happening with this other part of the function from which is 5 minus x. Let's look at the graph again. Y equals 5 minus x. So this is the second part of the graph from 3 onward. For 3 onward, this part of the function is valid. What's the range of this part of the function? Anyone? The blue part, the domain for this is x greater than 2. So to the right of this point A, that's the domain. What about the range of the second part of the function? Blue part. Anyone?
Is less than equal to 2.
Less than equal to? Y is less than 2. Range is in terms of y. So for the second part, so for the first part, the range was from 2 to 11. This was for the first part. Now for the second part, the range is below 2. So we could say the range for this part is y less than 2. Okay. Now, if the range of this part is y less than 2, what about the domain of this part? That's going to be x less than 2. So this is x less than 2. All right. And now, although this is also okay, but generally when we write functions like this, we write them in ascending order in the sense that the smaller values of x, they should be written above. So the first part of the function, it should have smaller values of x, and then the second part of the function should have the larger values of x. So we have found the domains to be like this, that square root of 11 minus x is valid from 2 to 11, and 5 minus x is valid for x less than 2. What are the smaller values of x? X less than 2. So it's better to write it like this. Write square root of 11 minus x here and 5 minus x above, because the function starts from 5 minus x in case of inverse. This is how this inverse function would look like in a similar way. Does that make sense?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. All right. Now, sometimes they also ask you to sketch the graph of such functions. So in other similar questions in the worksheet like this, I think at least in one of them, they ask you about graph of the inverse function as well. Now, even though they haven't asked about that in this particular question, let's see how the graph would look like if they had asked for it. Let's think about that. How the graph of the inverse function would have looked like in this case. Okay, so how would you draw the graph of this function, of the inverse function? This is the original function f of x. Now remember, f of x and f inverse of x, they are inverse of each other. They are reflections of each other in the line y equals x. On a graph, f of x and f inverse of x, they're supposed to be reflections of each other. So what we can do is, this point is 0, 11. Where will this point go in the inverse function? It would become 11, 0. So let's say this is 11. This point would go here. What about this point? This point is 3, 2. This would go to 2, 3. So let me mark that point somewhere here. This is the original function. This is 3 and 2. If you were to draw, if you were to mark a point corresponding to 3, 2 for the inverse function, that will be 2, 3. So let's say this is 2, and maybe this is 3. This might be another point that you have. And then below this is just going like this. Okay. So in order to draw the graph, what you can do is you can take another point on the original function for that straight line. You can say, let's take this point. What's this point going to be? It's a straight line. The equation of the line is y equals 5 minus x. what's the x-intercept of that graph? Y equals 5 minus x. The x-intercept is 5 in this case, right? You put y equal to 0. Sorry about that. If you input y equals 0, you get x equal to 5. This is the point that you get. Okay. Now this point is 5 and 0. Where is this point going to go in the inverse function? In the inverse function, this point is going to go to 0, 5. So let's say that's somewhere around here. Let's say this is 0, 5. So how would the graph look like now? This part is going to be a straight line like this. Okay. This is a reflection of y equals, this is the reflection of this line below. Remember the y equals x line, that would look something like this, passing from 2 to, so it might look like this, the y equals x line. These graphs are supposed to be reflections of that line. Okay. And now what about the right part? You have the curve is going to look something like this. This is going to be the graph of f inverse of x, if you had to draw that. Okay. Any problem with this?
Sir, do
Yes.
we have to draw the line y equals to x by measuring the angle?
Abdul Rahman, your voice is a bit distorted. Can you say that again?
Sir, should we draw the line y equals to x by taking the angle?
Not necessarily. Y equals x line can actually be drawn. So once you have marked the points, y equals x line is supposed to pass through all of these points. 2, 2, 3, 3, 4, 4, 5, 5. So if you have marked the points fairly accurately, this is what you should be getting. So you don't have to measure angle for that. Just mark points like this: 2, 2, 1, 1, 3, 3, 4, 4, and so on. Okay.
Yes, sir.
Okay. Any other questions?
Sir, when they say fx
Yes.
equals 11 minus x squared and 5 minus x, does it equal to both or like individually? Like, does fx equal to both of them at the same time?
Okay. Could you repeat the question? I'm sorry, I was distracted a bit.
Does fx equal to both equations at the same time, or is it individual?
No, f of x is equal to both of them because they're both valid for different intervals. The first expression is only valid for x between 0 and 3. So when the value of x that you input, if that is between 0 and 3, that goes into this expression. This is the operation that's applied on that. If the value of x that's input into the function, if that is, greater than 3, I wrote this greater than 2 instead here. If it's greater than 3, the value of x that you input, that goes into the second expression. So there's no conflict there as such. Whenever the value of x is between 0 and 3, this operation is applied. When it's greater than 3, the second operation is applied. So these expressions are valid for different values of x. So f of x is equal to this whole thing. That's how it's defined. That's for one range, one domain. It's going to apply this operation, 11 minus x squared. And for the rest of the domain, it's going to apply this operation. Okay.
Okay, thank you, sir.
All right. Okay, so are there no other questions from the worksheet? Abdullah, I can see that you are asking questions from another paper, I think, from a recent paper. We'll have a look at that, but no questions from worksheet. Should we move on to other questions then? Okay, so if you have no questions from the worksheet anymore, let's have a look at some from, I guess, some recent papers, Abdullah. Okay, so Abdullah sent a few questions on the WhatsApp group. Let me have a look at that. Okay, let's try this one now. I don't know what's happening to this. Okay, so it looks like a good question. Let's try this. So it says the function f and g, the functions f and g are defined for all values of x by f of x equals 3x minus 2 whole squared plus k, and g of x equals 5x minus 1. They're defined for all real values of x, so there's no restriction on the domains of these functions. Okay? All right. Now, it says given that the range of the function gf is gf of x greater than or equal to 39, find the value of k. Okay, so we have function f of x given, we've got function g of x given. It says given that the range of the function gf is gf of x greater than or equal to 39, we need to find the value of k. Now, first of all, what is the function gf? We need to find that function. All right, let's find the function gf. Let me write down those two functions here. Again, f of x equals 3x minus 2 whole squared plus k, and g of x equals 5x minus 1. Now, both of these functions are defined for all real values. That means there's no restriction on the input that these functions can take. So gf and fg, both of those functions can always be formed. All right. So because that condition that we used to have, that the range of the inner function should be part of the domain of the outer function. Now the domain of the outer function is all real values. So the composite function can always be formed. So we don't have that problem here at all. Let's first find gf function. How do you do that? Gf of x inside the function g of g, you have to input f. So it becomes g of f of x. All right. So that means g of 3x minus 2 whole squared plus k. And that gives us, so inside g, you have to input this now. So in place of x there, input this whole thing. So that becomes 5 into 3x minus 2 whole squared plus k minus 1. This is the function gf of x. Now what they're saying is, the range of the function gf is greater than or equal to 39. What's the range of a function? Range of a function is the y values of that function. So basically, the y value of this function is supposed to be greater than or equal to 39. Okay. So all you have to do is put this whole function greater than or equal to 39. Okay. What we can do is we can put this whole function greater than or equal to 39 like this. Okay.
Sir,
Because yes.
sir, I didn't understand this. Why did you put it greater than equal to 39?
Let's say you have a function f of x equals 2x minus 4. Or let's say instead you have f of x equals x minus 2 whole squared plus 1. You have a quadratic function. Okay. Now, what does this quadratic function look like? It's a U-shaped graph. So it's going to look like this. This is going to be the shape of the graph. All right. Now, since this is the shape of the graph, what's the turning point of this graph? Turning point of this graph is going to be 2 and 1. What's the range of this graph? The range of this function? The range of this function is f of x greater than equal to 1. Y greater than equal to 1, right? Y greater than equal to 1. Y is basically f of x. That is greater than equal to 1. So that basically means that this function is supposed to be, f of x is supposed to be greater than or equal to 1. Now, if f of x is greater than equal to 1, that means this whole thing, x minus 2 whole squared plus 1, that should be greater than equal to 1. Does that make sense? So f of x basically represents y of the function, right? The y coordinate of the function, because that's the value of the whole function. So if you write it like this, y equals x minus 2 whole squared plus 1, range gives you values of y. So if range is greater than or equal to 39, that means that whole function is supposed to be greater than or equal to 39. In this case, if the range is greater than or equal to 1, that means the whole function is supposed to be greater than or equal to 1. Does that make sense? Yes, no?
Yes, sir. Okay. Thank you.
Okay, now, in fact, it'll probably make it easier to think of it this way then. So let's get back to this. So it might make it easier for you to understand like this instead. That they're saying this quadratic function, the range of this quadratic function is what? The range of this quadratic
39.
function is greater than or equal to 39. It's not 39, it's greater than or equal to 39. Now, what type of function is this? It's a U-shaped graph, right? It's a U-shaped graph because the coefficient of x squared is going to turn out to be positive. If you square this and then multiply by 5, the coefficient of x squared is going to be positive. So it's a U-shaped graph like this. What they've actually told you is the range of the function is greater than or equal to 39. That means this turning point that you have, whatever is the x coordinate, the y coordinate is 39 because the range of the function is basically above this. 39 or more. Does that make sense?
Yes, sir.
Right? So the turning point is supposed to have its y coordinate equal to 39. Now what we can do is we can find the turning point for this function. Now the good thing is it's already in kind of a completed square form, not exactly the standard form, but it's very similar to that. If I were to multiply 5 inside, what does that give us? 5 into 3x minus 2 whole squared plus 5 times k minus 1. How do you find the turning point of a quadratic function from this form? Can you find the turning point of the y coordinate using this quadratic function? Can you do that? Remember the standard form, a into x minus h whole squared plus k. Basically, the x coordinate is found by putting this thing inside the bracket equal to 0. So x equals h. If you had some other coefficient of x here, you would have to put this thing equal to 0 and find the value of x from that. The y coordinate is always this constant that you've got outside. This is the y coordinate of the turning point, h and k, right? In this form, what we can say is this thing is the y coordinate of the turning point of this function. This is the y coordinate of the minimum point. If this is supposed to be the y coordinate of the minimum point, we already know the y coordinate of the minimum point. What's that? That's 39. So that means 5k minus 1 is supposed to be equal to 39. And that gives us 5k equal to 40. The value of k turns out to be 8 from this. So when the value of k is 8, the range of this function would be greater than or equal to 39. Is that okay?
Yes, sir.
No problems? Okay, let's have a look at the second part now. The second part says, for this value of k, determine the range of the function ft. Okay, so now they're talking about the function fg. So earlier they were talking about gf, now we have fg, all right? Okay, so we've got those two functions again, the same two functions. Let me write them here. Now we know the value for k, so we can input that here. The value of k is 8. We need to find the range of the function fg. Now, first of all, we have to find the function fg. What's fg? Fg of x. What does that become? That's f of g of x. Inside f, we have to input g. So that becomes f of 5x minus 1. So in place of x in this first function, you have to input 5x minus 1. What does that give you? 3 into 5x minus 1 minus 2 whole squared plus 8. If you simplify this, that's going to give you 15x minus 3 minus 2. That's 15x minus 5 whole squared plus 8. Now, this is also a quadratic function. And again, this is the completed square form. We need to find the range of this function. What's the domain of this function? Can you tell me what the domain of the domain of fg of x is going to be? What's the domain of the
5.
5? So domain is always, remember, it's a set of values, not a number. It's greater than something, less than something, between some values. What do you mean 5? What's the domain of this function? Anyone?
Domain is greater than or equal to 8.
Of the function.
No,
It's
I mean, no, I meant domain is greater than or equal to 1 - 1/3. I mean 1/3.
Remember what the domain of f of x is? What the question told us about this? Domain of f of x is all real values. What about domain of g of x? Domain of g of x is all real values. What about the domain of fg of x? The domain of a composite function is the same as the domain of the inner function. What's the inner function? G of x. So the domain of fg of x is also all real values. So the domain of this function, composite function, is also all real values. That means the quadratic curve that you have for this, all of this is going to all of this is going to be valid. Okay. So we just have to look at the turning point of this curve then, and that's going to give us the range. It's going to be a U-shaped curve as well, like this. Sorry, my drawing skills are not that good. Yeah, so maybe something like this. This is the turning point. What's the y-coordinate of the turning point? The y-coordinate of the turning point is 8. So that means the range of the of this function, that is going to be y greater than or equal to 8. That's the range of this function. Any problems?
No, sir.
Range is all real values. Okay. Any other? So in fact, we have part C of this as well. It says the function h is defined for all real values of x, and it's such that gh of x is 35x plus 19. Find an expression for g inverse of x, and hence or otherwise find an expression for h of x. Okay, now we've done this method earlier, right? How to figure out a function given an equation like this. Let's think about this. So first of all, they're saying find an expression for g inverse of x. Now, do we have can we find g inverse of x? That's pretty straightforward. Part C. We have the function g of x. The function g of x is equal to 5x minus 1. Right? What's the inverse of this function? You say let y equals g of x. And that gives you y equal to 5x minus 1. Make x the subject, and that will give you y plus 1 divided by 5. And then g inverse of x, that becomes x plus 1 divided by 5. Is that okay? That's g inverse of x. Now the question says, using this, find an expression for h of x such that gh of x is 35x plus 19. Let me write that down here, gh of x. gh of x is 35x plus 19. This is gh of x. What we need to find out is h of x. How can we do that? We have talked about this before.
So we will multiply it by g inverse.
Yes, so we don't say it multiplying because a function is not multiplied like that. We apply g inverse on both sides. And we apply it in the beginning on both sides, on the left side, because g is here. So in order to get rid of this g from the left side, we introduce a g inverse here. It's not called multiplication. We are applying g inverse, right? We're applying g inverse on the left side, g inverse of g of h of x. That equals g inverse of 35x plus 19. Does that make sense? So we apply g inverse on both sides in the beginning, on the left side, to get rid of this g. Now on the left side, g inverse and g, they cancel each other's effect. And we're left with h of x. That means h of x is equal to g inverse of 35x plus 19. So in the g inverse of x function, wherever you've got x, you've got to replace that with 35x plus 19. So that becomes 35x plus 19 plus 1 divided by 5. And that's going to give you, if you take 5 common in the numerator now, because you'll have 35x plus 20, you can take 5 common. That leaves you with 7x plus 4 whole divided by 5. And that means h of x equals 7x plus 4. And that's what we were looking for. And that's your final result. 35x plus, 7x plus 4. That's h of x. Make sense?
Yes, sir.
Okay, any other questions from the past papers or from the worksheet? Any other questions? No? All right, so I have one other question. It's from, again, a recent past paper, and it's a slightly difficult one. Let's just do that, and then we end this topic. Tomorrow we start function transformations. So this question I've taken. So Abdullah, can you tell me which question this question was from? Which paper this question was from? So I can write it here. You know that?
What, sir?
Which paper was this question from?
Oh, sir, it was from February, March 2024.
Okay, this was March 24. Okay. Can you share these papers with me as well? I haven't seen them yet. March 2024, paper 1, 2.
Sir, I was watching a YouTube video and they had that paper.
Oh, okay, so they generally come on Reddit. Maybe I'll search there. Okay. Anyway, we'll do them in the past paper session later, inshallah. November 2021, paper 1-3, question number 6. Do they still do YouTube videos of recent past papers?
Yes, sir. Sir, I can
Which
share
channel
the
are you,
link.
which channel are you talking about?
Sir, let me see.
Because they've actually Cambridge has started sending
Yes.
copyright strikes, unfortunately. So last year, a number
Sir,
of teachers got it. So
it is some random person who sold this. I can share
yeah,
the
okay.
link.
So basically, relatively more established channels, they're not taking the risk anymore
Yes, sir.
because of the copyright strikes. Okay, anyway, it's all right. Okay, so November 2021, paper 1-3, question number 6. Let's try this. Okay, so now this is a good one. Let's have a look at this. The diagram shows a graph of y equals f of x. On this diagram, we need to sketch the graph of y equals f inverse of x. All right, we need to draw the graph of f inverse of x. Now, we don't even know the f inverse function yet, right? We don't know how that looks like. And they're asking us to draw the graph of this function first. We need to sketch this graph. Now, how do you do that? We know that f of x and f inverse of x, they're supposed to be a reflection of each other in the line y equals x, right? So that's what we can do. We can draw a line y equals x and try to make a reflection in that graph, okay? So let me draw a line y equals x here. So this is what it would look like, 45-degree line, roughly. Okay, so let's say this is what it looks like. Now you need to reflect the graph f of x in this line. Okay. Now, how would you do that? How would you reflect this graph in this line? So remember, the reflection is basically done using perpendicular distance on both sides. So perpendicular distance of each point should be the same on both sides. So you can place your ruler like this, that, for example, this point, make a perpendicular like this with this line, whatever is the distance on this side, mark a point on the other side like this. So this point, for instance, I think it's going to go somewhere around here, maybe. Okay, so this point may go somewhere here. So mark points like this. You can use a ruler. Whatever is the distance on this side of the line, mark almost the same distance on the other side. That's one idea. Or another idea could be, now you don't have any points given here as such. You could roughly mark some points here like this. So for instance, you could say, just try to estimate this. If this is, let's say, -4, I'm just writing random values here. It does not have to be accurate. If this was -4, now this distance horizontally from this point is less than the vertical distance, right? You can see that the x coordinate of this point on the left side, the magnitude of that, that's less than the y coordinate. So if I call this -4, this would be, let's say, 6. Okay, so I'm just marking these points roughly like this. So this point could be, let's say, -4, 6. And then similarly, this point on the other side, it's kind of a symmetrical graph. So this is going to be 4 and -6. So I have these points here. Make sense? Now, what about f inverse of x? These points are going to get reversed. Where does -4, 6 go? So again, how am I getting these points? These are not actual points. I'm just taking the ratio kind of. So -4 and 6, I could also call them something like this. I could say this is -2, this is -2, this is 3, and so on, right? So I'm considering that the ratio looks something like this, 2:3 of the x coordinate and the y coordinate. You can use 4, 6, 2, 3, anything to that effect, okay? Now, where does this point go? This goes to 6 -4. So 6 here on the right side and -4 down, so maybe somewhere around here. I'm going to mark this point here. One point is coming here, okay? And similarly, where does this point go? 4 -6. This point goes to -6, 4. So maybe -6 is there, and then 4 is maybe here. So this point may be somewhere around here. And then you have origin. The point is going to pass through origin, so that is here. The graph is going to pass through origin because this is 0, 0, 0, 0 reversed is still 0, 0. Okay. And now you can try to sketch the graph of this function. How would the graph look like? You can see when these points are reflected, where they're going to go? Somewhere around here. When this point is reflected, it's going to go somewhere around here. So the shape of the graph is going to look something like this. It's going to look like this here, and then perhaps like this here. This is roughly what the f inverse of x graph would look like. Make sense? Now, it does not have to be accurate. It's just one mark because they just want to see if you have a rough idea of how the graph would look like. Okay. Any problem with this?
No, sir.
No, sir. Sir, I sent
It does.
the February March papers 2024 on the WhatsApp group chat.
Oh, that's good. So I'll not have to search for that. Thank you so much. If you have the others as well, apart from paper 1, you could send those as well.
I sent all of them.
Okay, that's great. Thank you. So I'll have a look at them later. Thank you. Okay, so we have part A done. So we have sketched the graph. Okay. Now, again, these points were just estimates. These are not actual points. Don't think of them as actual points. I'm going to erase them because of that. These are not actual points. Okay. This is how the rough sketch would look like. Okay. Now it says it's given that f of x equals minus x over square root of 4 minus x squared, where x is between minus 2 and 2. Find an expression for f inverse of x. Okay. Minus x over square root of 4 minus x squared. X is between minus 2 and 2. We need to find an expression for f inverse of x. Okay. How do you do that? So f of x is equal to minus x over square root of 4 minus x squared. We need to find the inverse of this function. The domain of this function is from minus 2 to 2. All right. Now, how do you start finding the inverse? You replace f of x with y. You say, let y equals f of x. That leaves you with y equals minus x over square root of 4 minus x squared. Okay. Now make x the subject. How can you do that? You can take the square root to the other side so that it becomes y into square root of 4 minus x squared. That equals minus x. Square both sides. When you square both sides, you end up with y squared into 4 minus x squared. On the other side, you have minus x whole squared. So the negative sign is going to get removed. So it becomes x squared. Okay. Now let's simplify this. This gives you 4y squared minus x squared y squared. That equals x squared. Take the x terms to one side. So you can say this is x squared, y squared plus x squared. On the other side, you've got 4y squared. All right. Now you take x common. When you take x common, that leaves you with x squared into y squared plus 1. And on the other side, you've got 4y squared. Take this y squared plus 1 to the other side, and you get x squared equals 4y squared divided by y squared plus 1. Okay, all good until this point? We're just making x the subject. That's all that we're doing. All right. Now is the final step. You have to take square root on both sides, right? Because you've got x squared, you want x only. So now you take square root on both sides. When you take square root, however, remember, you always have to put plus minus. So it becomes square root of 4y squared divided by y squared plus 1 and square root of that. Make sense? Now, the numerator could be simplified, and that would give you plus minus 2y over square root of y squared plus 1. This is what you end up getting. Now, remember, as with quadratic functions, you need to decide whether to use plus here or minus here. You can't use both of them. All right, because we have seen that before. When you have plus and minus, what that means is you get something like this. You have one part of the graph above, you have one part of the graph below. It's not even a function, right? Because one value of x will give you two values of y. It's not a function. You can't have both plus and minus in a function, in a square root function, because that is not going to be a function. It's going to fail that test. It's going to be one too many. So we have to choose one of the two. It's either plus or minus. How do we decide which one of the two we should use here? Should we use plus here? Should we use minus here? How do we figure that out? That's the question now. Now, what's the domain of the function? The domain of the function, so in quadratic functions, we used to look at the domain of the function, right? The domain is minus 2 to 2. Let's think of that. Can we figure out using that? Minus 2 to 2. So x is supposed to be between minus 2 and 2. Now, do you get that with plus or minus? Well, it's not quite clear because you have some negative values, you have some positive values. You could do it, you could use plus here or minus here. Both of them are possible, right? So how do you decide now? Should you use plus? Should you use minus? How do we figure that out? Domain is not helping because domain has some negative part, some positive part, so we can't be sure. All right. Now, let's look at the graph that we drew in the first part. So they asked us to draw this sketch. All right. They asked us to draw the sketch of the inverse function in the first part, f inverse of x. Now you see, you have plus here and minus here. Which one of them is going to give you this particular graph? Let's think about that. So focus on the inverse function. Focus on f inverse of x. When x value is positive, what's the y value? So when x value is positive in the inverse function, when x is on the right side, can you see what the y value is? Y value is negative. So when x is positive, the value of y is negative. All right. And when x is negative, the value of y is positive. So basically, if one is negative, the other is supposed to be positive. If we use a plus sign here, with the plus sign, if y is positive, x is also going to be positive. With a negative sign, on the other hand, if we have a negative sign here, if y is negative, x is going to be positive. Or if you have a negative sign here, if y is positive, x is going to become negative. And if y is negative, minus into minus, x is going to become positive. And that's exactly what we want. We want x and y to have different signs. If x is positive, y should be negative. And if x is negative, y should be positive. That's what we can see from the graph. The graph is either in the second quadrant or in the fourth quadrant. In the second quadrant, you can see x is negative, y is positive. In the fourth quadrant, x is positive, y is negative. They have different signs. The original graph was also in these same two quadrants, and you can see you have a negative sign with that as well. If you had a positive sign there, that would be instead somewhere around here. It would be in this region. It's not in that region. So x and y is supposed to have opposite signs. So that is why what we say is we should use a negative sign there, because again, we actually just leave it here. When x is negative, y is positive, and when x is positive, y is negative. They're supposed to have opposite signs. In order to have those opposite signs, the sign that we should be using here is the negative sign. X equals minus 2y over square root of y squared plus 1. That means f inverse of x function, that's minus 2x divided by square root of x squared plus 1. And that's the inverse function that we were looking for. Does that make sense? Any questions on this?
So, sir, if x and y were both positive and negative, yeah, in the same quadrants, it would be positive.
Yes. So basically, if this graph was here, if it was here, or it was here, then we need the same signs, right? In that case, we would need to have a positive sign there instead of negative sign. Okay?
Okay, sir, thank you.
Any other problems?
No, sir.
Okay, let's have a look at the next part. Just give me a minute. Okay, so that's for the second part. We have found the expression for f inverse of x. This was the trickier part of this question. Once you understand, basically selecting the sign was the tricky part, whether to put plus sign there or the negative sign there, right? So that's how we would approach it. Let's have a look at the next part now. It says the function g is defined by g of x equals to x, and x is between minus a and a. That's the domain of the function that we're given. Okay, now we have another function, which is g of x, and g of x equals 2 times x. X is between minus a and plus a. Okay, where a is a constant. State the maximum possible value of a for which fg can be formed. Okay, now this is also, I think, kind of tricky. Maximum possible value of a for which fg can be formed. Now it's a composite function. Remember the condition for forming a composite function? How do you, what's the condition for forming a composite function? Let me write that down here. The function that we're talking about is fg. Now let me write down the function f of x here as well. What was the function? The function f of x was minus x over square root of 4 minus x squared, and the domain was given to be from minus 2 to plus 2. That was the domain of the function. Okay. Now, what was the condition for forming a composite function? Fg. What's the inner function and what's the outer function? The inner function is g and the outer function is f. Let me write down the condition. You can think of in your head as well. You don't necessarily have to write it down. They only want the answer, right? I'm just going to write this for your notes and for your better understanding. In the exam, you would just write down the final result, the value of a, and that's the only thing that's going to get you marked. It's a 1 mark question. There's no explanation needed. You just need to write down the value, okay? But we need to understand how to get to that value. Let's think about that. Fg of x. Fg is a composite function. F is the outer function, g is the inner function. Now remember the condition that we used to have? The whole domain of the inner function, so that means, sorry, the whole range of the inner function, that means range of g, whole range of the inner function, it should be part of the domain of the outer function. What's the domain of the outer function? The domain of the outer function, f. That's x between minus 2 and 2. Remember that condition? We talked about this in composite functions. The whole range of the inner function should be part of the domain of the outer function, right? Now, what's the range of the inner function? Do we know that? Inner function is g. What would be the range of g? Range of g, if the domain is minus a to a, it's a straight line 2 times x. What would be the range of g? Y will be between minus 2a and plus 2a, right? If domain is from minus a to a, when you input x equal to minus a, that gives you minus 2a. When you input x equal to a, that gives you plus 2a. So the range of this function g is from minus 2a to plus 2a. What's the domain of f? Domain of the outer function. Domain of the outer function is from minus 2 to 2. Now, since all of it has to be part of the domain of f, what does that mean? 2a should correspond to 2. Minus 2 should correspond to minus 2a. You can use any of those two numbers. You can say 2a, for example, is equal to 2. That gives you a equal to 1. The largest possible a is equal to 1. If a was bigger than 1, if a was, let's say, 3, let's suppose, the range of this function would become minus 6 to 6, and then you can't input that in function f anymore because it's not part of that domain. So what's the largest possible value of a that you can have? You can have it equal to 1, because if it's equal to 1, then you'd be able to input all of that in the function f. Otherwise, you would not be able to do that. So that's the largest possible value of a, 1. So you just have to write 1 here, basically. Does that make sense? Any questions on this?
No, sir.
Okay. All right, let's have a look at the next part now, the last part, and then we end for today. Part D. So we're done with part A. Okay, now this was B actually. A was sketching the graph. And now D is assuming that fg can be formed. Find and simplify an expression for fg of x. Now you just have to find fg of x. That's kind of the easier part. Let's do that. Let's find the function fg of x. We've got both of those functions there already. F of g of x. Inside the function f, you have to input g. So basically f of 2x, right? G is 2x. We just have to find this. In place of x in this function, just input 2x. What does that become? Minus into 2x divided by square root of 4 minus. In place of x, put 2x. So it becomes 4 minus 2x whole squared. That is the function fg of x, but the question says, find and simplify this expression. This is only going to get you 1 mark. You also have to simplify this. All right. How do you simplify this? You can see if maybe there's some cancellation that can happen. Maybe you can simplify the denominator somehow. Let's see what we get when we try to do that. We have minus 2x divided by square root of 4 minus 4x squared. Okay. Now what we can do is we can take 4 common from the denominator. Inside square root, it becomes 4 into 1 minus x squared. All right. And now this 4 can be written outside. So it becomes minus 2x over square root of 4. What's that? That's 2. So 2 into square root of 1 minus x squared. 2 and 2 get cancelled. And we are left with minus x over square root of 1 minus x squared. That is fg of x. There's not much that you can do with the square root here as such. You can write the expression inside as 1 plus x into 1 minus x, but that doesn't help. That cannot help us remove the square root. So we can just leave it like this. And that's the function fg of x. Sorry, that's the function fg of x. That's what we were looking for. And that's it. All right. So tomorrow at around 2:15 to 2:20, inshallah, we start function transformations. This is it for now. So those of you who are on YouTube, I have this past paper session starting. Just a reminder of that. From 13th of April, you can see the link for that. There is the registration link for that in the description below, and also in the chat box on the right side. If you have any questions, you can send me a message on Instagram or on WhatsApp if you have any queries about that. The registration link is there. All the details about the session are available there. I will also be posting posting my answers to some frequently asked questions in the next couple of days, maybe tomorrow, or if not tomorrow, latest by the 3rd of April. So some of you have been asking me which years are going to be covered, how many classes we're going to have each week. So I've been answering some of those questions verbally and individually to the people who've been asking me, but I'll try to summarize all of that information and try to post that maybe sometime tomorrow or the day after tomorrow on my Instagram and on YouTube, so that most of those questions are answered. But briefly, we will be focusing on all the papers from 2020 to 2024, all variants. Now, we would not be able to do all of them live. I have recordings available for a number of them. We will be, I am expecting that we will be doing around 50 to 60% of that live, and the rest of that will be available as recordings. But we would be covering all papers from 2020 to 2024 eventually. All right, so all of them are going to be there. Some of them are going to be solved in full. Some of them you will be telling me, so those of you are there in the group, You'll be telling me which questions you're finding difficult. We will be focusing on those questions in particular, right? So from every session, for every component, we will be doing one full paper, inshallah, the one with the lowest threshold, the one that is kind of the most difficult. And for the other two variants, you will be telling me which questions you're finding difficult, and we will be focusing on those questions in particular. And as we go closer to the exam, we'll also have a couple of sessions for each component in which you can ask any individual questions on any of the other past papers that you want to ask. We would also discuss them. Now, those of you are concerned about the number of years that we should be doing 8 to 10 years or something. First of all, it's not possible because 8 to 10 years means 10 years basically means you have 7 papers for each component every single year, right? 7 papers. 1 March, 3 June, 3 November, that's 7 papers in a year. 10 years means 70 papers for one component. If you want to do that, for that you would have to start like 3 months early, right? And anybody who's saying that you will be doing so any session for any subject, if you if somebody if it's marketed like this that you're doing 10 years of papers, generally what happens is you do one variant of each paper, one variant of each year. Then that is possible then that you do one variant for each session. But for maths in particular, in my experience, the papers from before 2020, most people do them while they're covering the topics, they do them as topicals, right? And from 2020 onward, you would see this, you would have the last syllabus change in 2020. So all the questions that you find 2020 onward, they're relevant for you. And you will find in some recent papers, 2022 onward, that the difficulty level has also started slightly increasing, and the pattern of questions has also slightly changed as compared to what it used to be before. So like 7-8 questions in every paper, you get very similar to what you used to get earlier. But then there are like 3 questions in every paper on average that are slightly different. You have to think on this part. So it's more important to do all variants, every single question from the last 3-4 years. So that's what I would want to focus on, that we are able to do all of the last 3-4 years of papers, 2020, so last 4 years of papers at least, because that's going to be most beneficial at this point in time. Okay, so we could do at least all the difficult questions from all papers, and then full length papers for some of those variants as well. All right, so you can find the rest of the information in that registration link. The fee details, the class schedule, etc. I'll be clarifying the class schedule a bit more as well. I've been getting some queries about that as well, about how the class schedule is going to be, how many classes per week for each component. I'll try to clarify all of that in a couple of posts, maybe tomorrow or the day after tomorrow, to make it clear. All right. So if you have any questions, you can always post them on the WhatsApp, on my WhatsApp or on Instagram. I'll try to respond to them gradually. Now I have a lot of queries coming, so it takes time to respond to all of them. But I will get back eventually. All right. Okay, so that was for everyone out there. Now, you guys in the meeting, let me know if you have any other questions, any quick questions, or is that it?
Sir, what other topics are left to cover?
So we are done with functions. Now functions has one part left, that is function transformations. That's going to take us 2-3 days. So we start that tomorrow. Tomorrow is Tuesday. So Tuesday, Wednesday, Thursday. And then we have APGP and equation of circle, right? So there are 2 small topics. That's going to take us like 2-3 days each. So at some point next week, we should be at least done with the concepts, and maybe we might need one more session after that to do some more practice. But this week, I'm expecting to cover function transformations, and along with that, possibly equation of circle as well. All right. And then for next week, we would just have AP and GP left. All right.
Okay, sir. Thank you.
Anything else?
No, sir.
So basically with functions, we are done with all the major P1 topics because functions was the last major one. Now the rest of them, they're relatively simpler. Equation of circle, the concepts for that are quite straightforward. Sometimes some questions tend to be tricky, but we'll do some practice on that. But in terms of the relatively more difficult topics, we're done with all of them. So basically that's quadratics, trigonometry, differentiation, integration, functions. So all the major topics, we're done with them, right? So after function transformations, we should be done with all the major ones. And now we have a couple of small ones left, which we will be covering in the next week or so in China. All right, so that's it for today. I'll see you again tomorrow. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.